This
topics like
conference will now be recorded.
uh, Chat GPT versus LLMs. And also, I would like to discuss some important NLP related papers which I published in reputed journals. This is my agenda. And coming to basic concepts, first, before going to NLP, natural language processing, we should know, we have to know the architecture of AI, what are the relationship between AI, machine learning, and deep learning. So all of you know what is artificial intelligence. The basic brief definition is ability of machines to intimate human intelligence. So artificial intelligence algorithms take over some rules which we framed. We means humans framed. So based on the rules, the algorithms will work. And coming to machine learning, algorithms to incorporate intelligence into machine by automatically learning from data. So in this machine learning, all we know, we provide some data to the models. Some models gain some knowledge from the data set. So based on that knowledge, further, if you give any predictions, any input, it will give some output. So that's machine learning algorithms will do. So coming to deep learning, the algorithms that mimics human brain to incorporate intelligence into machine. In this deep learning definition, the mimics human brain. Human brain means we have so many neurons. So neurons, every neuron is connected to another neuron with some links. Likewise, here in real time, by using computer science technology, we created some artificial neurons. Artificial neurons. Based on that, if we provide a large data set, the large data set to the model can train and they can predict with very accurate values when compared to machine learning. So by seeing this picture, this deep learning is subset of ML and ML is subset of artificial intelligence. So coming to NLP, where our NLP is fit in this model. So coming to NLP, natural language processing is multidisciplinary course area. This NLP uses artificial intelligence techniques. If I say artificial intelligence means they can use ML models, they can use deep learning models, and also some computer science techniques like algorithms, time complexity. How can we design algorithms? So that's why the NLP sits in the middle of computer science, artificial intelligence, and human language. Why we put human language here? Human language is some language related knowledge, so linguistics. So we are NLP means natural language processing. Natural languages are what we are communicating, daily communicating with some language. So this English, local language like Hindi, Telugu, Tamil, Kannada, these are all natural languages. So every language has its own grammatical structure, grammar rules. So that type of area comes under human language. So that's why NLP is comes under all this intersection of computer science into AI and human languages. And history of NLP, if you see history of NLP, it starts in mid 1980s. So at that time, some starts with some grammatical rules, syntactical rules. If you provide set of rules to the computer, based on the rules, the computer system can predict, okay, what is net or what is like that. And statistical approaches means using some mathematical relations, mathematical related formulas like logarithms, some formulas. Based on that, the computers are working where computers were work in the form of recurrent neural networks, RNN, hidden Markov model, and LSTM. Coming to 2000, after 2000 year, so the technology developed. In that developed, we have some pre-trained word-to-vec embeddings are there, and we'll discuss what is word embeddings and sequence-to-sequence learning. So this is comes under the how we extract the content from the text. So coming to 2019 onwards, we have GPUs. We have a lot of GPUs. We have very efficient HPC computers, high performance computers, and supercomputers. So by using these hardware technology, we improved a lot, and we can train a model with huge data. huge data. So that comes under robot, bot, t5, gpt. So all these new models come every month, every year. We have so many new models. So what is the motivation of NLP? So understand language analysis and generation. So why we are studying NLP? Okay, if you know English, I know English, we can easily communicate with that language English. So if you know local language Telugu, if I know Telugu, we can easily communicate with Telugu. But why we are learning, why we are developing these type of algorithms or techniques means we have to train the machines in the sense we have to train the computers what exactly we are thinking while speaking, while understanding, while predicting what is the next word. So that comes under understand language analysis and generation. And also sometimes it should give some output in the form of text. So communication means we need some language for communication. That may be any natural language. So language is a window to the mind. This is some quotation. So before think, then before talk, if you are think anything in your mind that can we can speak in some form of some language. So data is a semantic form. So what is semantic? So the data should be in a semantic meaningful form. Then only we can understand. I say something without following any grammar, you can't understand. So data is in semantic form. So nowadays, data in real-time data can be structured. Data is available in three forms, mainly structured, semi-structured, and unstructured. The structured means all we know database management systems. In that, we are creating some tables by using normal forms. So what we means is, so structured means every attribute, every column has a single variable, and we should follow some rules, and we will frame every data into the table. So semi-structured means XML, XML form. If we know the web technologies, in that we are using some XML forms to data store. The data should be in some semi-structured means our own tags. In the tags, we have to create some structures, some data format, not exactly tables, not exactly unstructured. So coming to unstructured. So unstructured is in social media. Unstructured means there is no particular structure. That means we are communicating daily in social media with a plain text. Hi, how are you? What are you doing? So this is not a structured format. So general format. So in this NLP, we are dealing with this unstructured data. So these three types of data, but in table form, we can easily extract tables by using select star command by SQL commands and all those things. And we can extract XML also by using, we can extract text from XML file also. But coming to unstructured data, how can we deal? How can we analyze? So for that, we need some techniques. So this NLP course, this NLP subject deals about the analysis of text. So what is natural language processing? Is a branch of artificial intelligence. So within a computer science that focuses on helping computers to understand the way that humans write and speak. So exactly we need some computer missions or systems, exactly what we are write and speak. And another definition refers to the branch of computer science and more specifically the branch of AI concerned with giving computers the ability to understand text, what we are saying. It should understand what we are saying. And also based on our voice, our input, it should give some related output. So NLP enables computers to understand natural NLP humans to where the language is spoken, same thing. But here some applications allows machine to break down the interpret human language. Core of tools we use every day from translation software, chatbots, spam filters, and search engines to grammar correction softwares, voice assistants, and social media monitoring tools. Next slide. So real-time applications like we are asking some, we are dealing with, we are talking with some hardware devices like Alexa. If you ask any question, it will give some reply. So it will search that answer through any internet sources, and it should give some reply. So how it works, how it analyze our voice, how analyze our content, and also spam detection. In nowadays all we have emails in that, so which one is authorized, which one is safe, which one is not safe. So automatic detection based on the content of the email. So we have some NLP techniques. Automatically that techniques segregate or classify which email comes under spam or not a spam. And sentiment analysis based on your text. Hello, how are you? Is that plain text? Oh, you are a good boy, you are a bad boy. Based on our words, based on our content in the text, it should give some sentiment, is a positive, negative, or bad words, bad content, good content. How much bad? Again, that levels up to 5, plus 1, plus 2, plus 3, plus 4. These all are comes under this sentiment analysis. And also machine translation. Nowadays we have some websites or so many online websites are there. If you want to know the exact meaning of English to some other language, if you put that English in that box, if you click mission translate, we will get the particular same meaning in other language like Hindi or Telugu or Tamil, etc. And also nowadays we are having some spelling corrections, Grammarly, Quillboard. We are using as a researchers or a computer science students while writing, while designing any content. We use some online applications, the spell corrections. These all uses NLP technique. And chatbot. Nowadays, chatbot, any bank websites or any hospital websites, they are providing some chatbots. If you have minimal, they reduce the manpower by using these chatbots. And some other applications already we discussed. So, due to time concern, I will skip some slides. So NLP pipeline, main components of generic pipeline NLP system. So here NLP in last yesterday session, computer vision, computer image processing. So all these comes under first if we know the what are the features, and computer can understand only numbers. I think all of you know computer can understand all the numbers. So if you provide any input like image, it will convert that image into numbers, then only it can proceed. Like NLP, if you provide any text, it should convert into numbers, then only it can proceed. So here, for any model, for any model, it needs some data. Here, data acquisition. Before that, in data acquisition, in raw data, it has some noisy data, some unwanted data, some unwanted symbols we have to clean. Like before cooking our food, we need some pre-processing. So we do some wash. After that we remove some unwanted things like that. Here data also, if you provide good data, then a model also model will also try it very accurately and it will give good results. So after that some pre-processing steps. So pre-processing, in that we will discuss what are the pre-processing steps. And feature engineering, what are the important things from the data, how can we get the important features. So by using some feature engineering. After that, the remaining data we have to give to the model. We have to give to the model. 1 minute. So give to the model. So after model evaluation, how much the model gives the values, is it accurate or not? And after that deployment, if your model is ready or working properly, then real time, if you put it in any cloud or any real time web application, so then it will use to the society. So data acquisition, the raw textual data, so public data sets, emails. Suppose if I want to deal with the tweets, so I need Twitter data. So data like that. And the text cleaning. So sometimes our accurate data is not very clean. So it maybe contains some HTML tags, spelling mistakes, special characters, some unwanted symbols. We have to remove that in the text cleaning process. So coming to pre-processing. So suppose if we want to cook vegetables, so after cleaning all those things, okay, then after that for we have to cut the vegetables up to some pieces. So based on our need, like that here, some text pre-processing. Before giving to the model, we need some text pre-processing techniques are there. So first tokenization. So we have to split entire text. Text may be sentence, paragraph, document. We have to split the every sentence or paragraph into single words. So here I love NLP. So here after splitting tokenize I love NLP. So lowercase converting all text. So lowercase, why we are going for lowercase? Some text as a capital letters, small letters. For uniformly, we have to maintain some case here lowercase. Some natural language processing. We convert natural lowercase. We'll get this one natural language processing. Otherwise, the system will take capital N is another word, small n is another word. So to avoid this type of ambiguities, so convert all the text into lowercase and stop word removal in text. So we need only important words, non-informative, and we have to eliminate non-informative words. So what are the non-informative words? Based on base our task only. So for example, here the is and for grammatical we need this, but for informative purpose we doesn't need. We eliminate non-informative words. And coming to lemmatization and stemming, some words are different forms. Suppose run is the base form or root form for running. So if you apply this limitation stemming, we will get a unique words other than the running, ran like that. And also eat, and ate. If you apply limitation, we will get only single unique word. And also punctuations and the special character removal. Even in text processing, if you have any other unnecessary things, remove unnecessary symbols or noise. Coming to parts of speech tagging involve assigning a part of speech tag to each word in a text. So here, parts of speech means we have to give the which word is belongs to parts of speech. I think all of you know parts of speech means nouns, verbs, pronouns, prepositions. We have to give. Why? Because we will discuss. Why? Because means, okay, we have to analyze the structure of the sentence. Suppose we are using English. So English, the every sentence starts with some either determined or noun, not with some verbs. So like that we have to analyze given sentence is correct or not. For that we have to analyze with parts of speech tagging techniques. And future engineering, for future extraction, we have methods like one hot encoder, bag of words, engrams, TF-IDF, what to work. We will discuss next. So modeling means model building. So model building, we have to train the model. How we train the model? We have some models like machine learning approach models are there, deep learning models are there. So we have to finally give these raw data. I mean, after pre-processing the text, we have to give to the models. So model evaluation. So use multiple metrics. And I think all of you know the metrics like accuracy, recall, precision. By using that, we can estimate, we can predict, okay, given output is very accurate. So given model trained very well. So deployment means we have to deploy that into a cloud or servers of the users. Up to this, okay, what are the challenges in NLP? So lexical ambiguity and syntactic ambiguity. Suppose sometimes same word like bank gives different meanings, a river bank and a Bank of India. So at that time, we have to know which bank gives which type of meaning. Syntactical ambiguity. Sometimes even though the single word gives the single meaning, but sentence have multiple valid grammatical interpretations. That means I saw the man with a telescope. I saw the man, which man? So some syntactic ambiguity, and also misspellings. Nowadays we have seen any chart, WhatsApp or something. We have to give some content or give the types of words. Sometimes misspellings. We have to identify that what is the correct meaning of that word. So multilingual and cross language challenges. Sometimes we mix in English or local language, Telugu with English or Telugu with Tamil, Telugu with Hindi. So develop systems that handle multiple languages or translate between them accurately is hard due to the varying syntax, grammar, idiomatic expressions. So challenging in data quality. So Quality means you have to, if you provide unnecessary data to the machine, it can't train properly. And dynamic and evolving languages. Language constantly changes with the new words. Nowadays in social media, we are creating some new words. We are giving new words for good night, actually GNT something, some shortcuts, slangs, or phrases. So to identify that type of new words is very difficult. So domain adoption, NLP models trained on general data may not perform well in specialized domains. Suppose in medicine prescriptions. So I want to identify medical prescriptions. This is very complex or very challenging in NLP. The low resource languages. These are the problems all researchers are working on this type of challenges, in especially in NLP. Low resource languages. Many languages lack large, high quality data sets and making it challenging to build robust NLP systems for these languages. Okay, in India, some languages doesn't have some lipi. Lipi means there is no correct grammar rules, and without that, how can we build data sets? So to identify that type of languages or prediction of next word for that languages is very challenging. So coming to text pre-processing techniques. So text pre-processing is done already. Why we need pre-processing techniques? So here we have documents and language detection and pre-processing and model. So after this only we can go for either classification or sentiment analysis, entity extraction, and topic modeling, and document similarity. If you give any documents, how much similarity between the document. So for this, for implementation of these pre-processing tasks, we need some package. Suppose the programming point of view, so we need NLTK library. So Natural Language Toolkit is powerful and widely used Python library for processing and analyzing human language data. So for that, we have to first install pip install NLTK. So we have variety of tasks can be performed by using this NLTK. So we have to first pip install, after that import NLTK. So tokenization. So already we discussed these are the pre-processing steps. Tokenization, we have to tokens or divide entire sentence into small words or tokens. Lowercase conversion, stop word removal, stemming, lemmatization, parse or syntax tree generation, POS tagging. For all these, we need this package. So same pre-processing techniques, and I will discuss with uh, important topics like sentence splitter. Okay, split the text into sentences. Word tokenize, split a sentence into words. Stop word stemming. Okay, some small program point of view. If you give an import NLTK, directly can import sentence tokenize. We can divide sentence wise as well as word wise. So if you want word wise, word underscore tokenize. If you want sentences, sentence underscore tokenize. Stop word removal. So already we discussed what are the stop words, these, the, is, at, which, in, or, of. We have to remove. How can we remove these stop words? So here, so these first we have to import this NLTK, this NLTK. Then, a minute. Okay. Okay, first we have to import NLTK, then NLTK corpus import stop words. First, for stop words already predefined in the software, but we have to download what are the softwares, what are the stop words. After that, see here, we are word lower not in stop words. We need the tokens, but the tokens should be not in the stop words. Means we are eliminating stop words here, and after that, we are printing. This is original text. This is a sample sentence and it contains some stop words. Then after applying, after removing stop words, those simple, this is a, these three words are not informative. So remove this, we remove the simple sentence, and also removed it, also removed contents, some also removed stop and words. And same thing, another example. And also rare words. What are the rare words? So rare word removal is a technique in NLP where words that occur infrequently. Frequently means not a rare word. Infrequently. So sometimes out of 100 times or out of 100 documents, out of 100 records, only one time it comes to it, we can say as a infrequently. So some data set. So this is NLTK and probability, and we have to give, and also software. I mean, by along with the package, we are getting some rare words. So this is a sample, and we can apply if rare word removals. We will get only some important words like words and common or rare. So the here like xenopathy, xenophone is a rare word, very rare word. So we have to remove this type of rare words as well as stop words. So coming to stemming, so already discussed stemming for base form, for getting base form, running, runs, runner, we need only the base form of these, all these words is a run. So here three types of stemming are there. You have quarter stemming and Lancaster stemming, snowball stemmers. So remove the suffixes. Suffix, I think prefix, suffix, or if you know, suffix means ending. So like here runs, if you remove s, that is the s is a suffix here. So after removing of this x, we are getting run. Like here, a Lancaster stemming uses some rules, not blindly go for suffix. Use some rules. Sometimes we may delete prefix characters also. Sometimes suffix characters. And also we have to follow, we have to see the dictionary as well as dictionary words to reduce the words to their stem. But is the Lancaster stemmer is supports only one language like here English. Next, another type of stemmer is snowball stemmer. It supports multiple languages. Apart from this English, again, it supports some other languages like Spanish, French, and coming to India in Hindi. So these are the program examples. So here, if you apply both the stemmer, so run, fly. So actually, I fell my fly, but sometimes we may get only deletes es. Here, ly, ed. Land scatter supports English, snowball, another RGX expression stemmer also there, but it also works almost same. So coming to lemmatization, so lemmatization reducing a word to its root form. So what is root form? What is base form? Suppose if you give running, 1 minute. So if you give running, if you apply stemming, it gives run. Suppose 8, if you apply stemming, it gives only 8 or some other wrong prediction. But to avoid this, if you apply instead of stemming lemmatization, will get eat. So this is the eat is the root form of 8. 1 minute. Yeah. So eat is root form of 8, but it is not a base form. This run is a base form of running. In this case, run is both base and root form of running. But in this case, eat is a root form of 8. So this is the difference between root form and base form. So programming, I will share the PPT, then you can easily extract the code and execute. The spelling correction using edit distance method. So sometimes we may give some wrong spellings instead of some small misspellings like deletions. Okay, not an example here. Okay, method THO. So it almost equal to or very nearer distance to method. So the distance calculation is edit distance calculation is there based on the calculations which from which this word is very nearer. So by calculating the distance value, we can correct it. Okay, this is D. Here also the probability value. The probability is METHO is almost equal to some word in already vector space. Suppose here examples, example. So correct word is very nearer to example and run spelling mistake, cricket spelling mistake. So which word is very nearer to that word? So automatically system correct and so combination of all these techniques here, NLTK, tokenize, import word in one program. So coming to techniques used in NLP, okay, some techniques are there. Which techniques? I mentioned only small techniques because of time constraint. I use small techniques. Named entity recognition. So by using this, if you apply this named entity recognition, we can easily identify who are the persons in the given text and what are the places and company names, person names, and date or some timestamps and any organization names or country names like India. Okay, if you apply this NAR to the text, we can easily identify the person's names, country names, and places, date, all those things. So NAR in a paragraph is can be used for customer services and medical purposes and document categorization. For example, extracting aspects from customer reviews with NAR helps identification of semantics or extracting medical disease or drug from a text helps identification of the treatment. If you have text in that some drug name is there or some drug name you have to use otherwise the expiry date is there, drug name expiry date we have to identify. We are unable to identify in a from a large corpus large text. So further if you apply this technique NAR we can this NAR can easily identify that type of drug name or date related information or company related information or country related information. So all those things and parts of speech tagging. So parts of speech tagging is here. So here list of words, how can we get list of words after tokenization? We are getting some list of words. So we are assigning this list of words to the some parts of speech. Parts of speech means either that word gives, I mean related to preposition or verb or noun, determine, etc. So here the tag is case of its parts of speech. These form first one is word and second tag is this word is related to which type of parts of speech. Okay, here example is there. So here one word she sells, she sells on the seashore. So for this is preposition and verb and again noun, the injections and determine and noun. Like that, if you apply previous tagging, every text, if you provide a text, after applying previous tag, every word in the text comes with tags with POS. So what are the uses here? So it uses the special label assignment to each token, the parts of speech, and often also other grammatical categories such as tense, number, plurals. We have to identify Okay, given sentence is following the correct grammatical grammar or not. And also corpus searches in text analysis tools and algorithms can easily analyze the text is correct in the form of or not. And use of also speech tagging in NLP. What are the uses to understand the grammatical structure? What we discussed. To disambiguate words with multiple meaning. Sometimes some word gives multiple meaning. So next slide I will discuss. To improve the accuracy of NLP tasks. So for model training, we have to give good text, good input to the model. So for improving that model accuracy, first we have to give the correct input to the model. To how we can check correct input, suppose parts of speech tagging is correct to the other words. Suppose that given sentence is following grammar rule, then obviously our model also will train very well. And to facilitate research in linguistics, any new techniques in a language or linguistics, language related models, any research related, we can improve by using parts of speech. Suppose, for example, the ambiguity, disambiguity. Suppose here C1, the back door. Here the back is give some meaning. Okay, let me know what is back here, which type of parts of speech here. On my back and with the water's back promised to back the bill. So here I wrote four different sentences, but here back is the common word in all the four sentences. But in first sentence, back gives different related to different parts of speech. Let me know anyone which type of parts of speech in the first sentence back and second sentence, third, fourth. So JJ means adjective. The short form, we have some table. Actually, in time constraint, I'm unable to show that table to you. So the shape adjective, some shortcut like JJ. So on my back is that noun. In this second sentence, it belongs to noun. When the water's back means it's also again adjective. Which type of waters? So promise to back the bill. The verb back the bill. So same word here back gives different meaning. Like State Bank of India. That in that case, that bank related to some financial related. River bank, so river side. So that it gives the type of meaning. And also here the can was rusted. So tell me anyone the can related which type of parts of speech the can was rusted. The determinant can MD. If you think MD, mod, generally can, will, shall belongs to mad, mode. I mean that parts of speech and was verb rusted again over. But in real time, so mad comes under. Sorry, this can is a noun. The can was rusted. I'm talking about some water can. Some can was rusted. Which was rusted. Some can. So here this belongs to this time it belongs to sorry 1 minute. So belongs to noun and here rusted. This belongs to verb past tense. So the shortcuts. And coming to parser. So parser is very important while the given sentence is following correct grammar rule or not. Here is a compiler or interpreter component that breaks data into smaller elements. In compiler design, I think we know the parsers. So parsers are two types in top down and bottom up. So parser is a compiler that is used to break the data into smaller elements coming from lexical analysis phrase. Why we are discussing here the lexical analysis phrase? Because NLP, so that depends on contents or compiler some we have to deal with the small content small elements And also parser takes input in the form of sequence of tokens. Here tokens means the words and produces output in the form of parse tree. If you give the words sequence of sentence, internally it can break the sentence into tokens. Tokens means words. After that, our output is it will produce some tree format. Okay, first starts with any determine or noun. After that, followed by some verb, some adjective. So some every language has its own rule. If you first construct a tree, then if you give any sentence, the sentence obeys the rules of all the that languages. Then that means okay, the given sentence is correct, following correct grammar rule. So here, so many parsers are there. Here, I would like to explain one parser technique, that is shift reduce parser technique. The shift reduce parser is a simple kind of bottom-up parser. So by using this, similar done in bottom-up parser, that is parse tree is constructed from leaves. Bottom means, I think all of you know data structures. In tree concept, we have bottom leaves are there and root from top main bottom to up. So here I would like to explain with one example, that is here one grammar rule. It's a grammar rule. Suppose if you take English, so that is some noun followed by the verb or verb followed by some adjective like that. It's commonly in compiler design. Okay, this is some grammar. So this is the input buffer, the input text. Here we use one data structure, that is tag. Initially it is dollar means end. Okay, first one, we have to verify this given input text. Here commonly take ID plus ID plus ID. This is correct or not? Is correct following these correct rules or not? Okay, first we have to shift. Shift means here delete and put it in stack. Put it in stack. So that is dollar ID. Next, there is no dollar ID means we have to replace with s. So that's why reduce this one and after shift and id means s. Okay, we replaced id with s. Again plus is there. So s plus, there is no s plus here. So next again we can again go for next step, that is again shift id. So s plus id. So again id is s. So replace id with s means s plus s. Then again next operator is plus, again plus, there is no s plus, so wait for next element, that is id, again s plus id. So id means again s, so s plus s. So we have s plus s one, right component is there, that is s plus s is s, we replace with s. So we reached this, finally we reached the left side element. Here in the input buffer also no element operator or operators are there. So that's why we can say this input string is valid or accept by the given grammar. So these parse trees are validating the given text is following the grammar rules for a particular language or not, particular language or not. So coming to types of models, here future extraction. We need some futures. Futures means important things. So here we have some unsupervised learning, supervised learning. I think all of you know machine learning. Yesterday talk, Saab discussed supervised learning and unsupervised learning. In this supervised learning, we have decision tree, Bayesian, linear analysis, KNN, SVM, and neural networks. So for this, actually we need some features. We are identifying, suppose the small boy, small child, identify any person with some features, or identifying some objects with some features. So like that here, every model, they need some features to identify, but if it comes under image, okay, we need some important features. identify object, important features, identify person, important features. So how we can get these features? So future extraction. So we'll talk about the future. Like how can we extract the futures? So futures here already we discussed. So computers can understand only numbers. Only numbers. If you provide any image, the image also converted into some number format, grayscale format, 0 to 255. Then only computer models or deep learning models, CNN, YOLO, anything can access or analyze the type of image. Like that here NLP. In NLP means we are talking about only the text. Computer vision, they are speaking about only image related, picture related or pixel related. So here manual features, sometimes we have to provide, okay, this word is belongs to, okay, this number. I have to provide manual features. So bag of words features. We have these are the techniques, TF-IDF and n-grams, word embeddings. These are very important. If the future extraction, if we convert the text into the numbers efficiently, then only the model can train very well. We'll discuss back of words, TF-IDF, and word embeddings very quickly. Okay, there's some coming to machine learning. We have to provide features externally. Externally, coming to deep learning, automatically the model can extract the features. Automatically extract the features. I think all of you know. Then, okay, word embeddings. In that word embeddings, already TF-IDF, one hot encoding, bag of words, TF-IDF, and word embeddings. In coming to word embeddings, we have some specific techniques are there. Word to vec, glove, fast text. So same thing here. Anything we should convert into some numbers. Some numbers. Then only system can understand. Sorry, important terms, common terms used while represent text in NLP is very important. Corpus. What is corpus? Suppose if you are provide hundred of documents to the system, that all 100 documents text, we can call as a corpus. So next vocabulary. These consists of all unique. In that 100 documents, we have some unique words. We have to represent the unique words in a some presentation, or then we can call a separation with some commas or something, put it in some data structure. So we can call as a corpus, unique words. So document means one single text record, only one document, one single text record of a data set is a document. Okay, some in some books, document means a paragraphs or something. So one single text record we can call as a document. Then words are, if you know, the tokens. Which words are present in this vocabulary? Unique words. Or after applying what tokenize, we are getting tokenization. So the tokens or words you can call as a words. So text representation techniques. So here the word, the text is finally we have to convert into numbers. So for converting these numbers, we have some techniques. So one hot encoding, bag of words, TF-IDF, word embeddings. So important. I will go to the next one. Encoding means here represent words in a binary vector. So binary vector means here if you suppose I love NLP. If you tokenize, after tokenize, you are getting I love NLP. So here vocabulary means here unique words are I love NLP. These are the unique words. So coming to next, SN indexes or indices. I think are in data structures. Arrays starting with a of zero. This zero is we can call as index or index. So we are assigning some indices to the every word in the vocabulary. After that, assigning values. Okay, here I. These are already unique values. So that's why first one, I put one, remaining all are zeros. Remaining second love. So second one, second value one. Remaining places, remaining indices places zero. So NLP in second indices one, remaining zero place zero, one place zero. So likewise, we have to assign for this vocabulary. For this vocabulary, I'm assigning 1 0 0 0 1 0 0 0 1. So if you combine all this, so total I love NLP. If you combine 1 0 0 0 1 0 0 0 1. So this is one type of representation. I love NLP after converting this text into number representation, binary representation. Why I am saying binary? Here I used only ones and zeros, two values. Some examples for this. Some examples here. The size of this vector, it depends on unique values. My unique vocabulary here: 1, 2, 3, 4, 5, 6, 7. Here I am not applying stop word removal, so some words are coming here. So 7, 1, 2, 3, 4, 5, 6, 7. So this size is depends on vocabulary size. So what are the drawbacks according to what I will share? So disadvantages: one hot encoding creates a large vector. Suppose for simple example, it gives 7 size. If you deal with thousands of words, suppose your vocabulary size is equal to 1000. So that's vector size is 1000 size. Okay, 1000 size. But even we are finding only one value. The value is only one. Remaining all are zeros. So that is second one. So vectors, encoder vectors are zero, leading to sparse vectors. Sparse means vector size more, but there is no use. There is no semantic relationship between words. Only we are identifying, instead of words, we are identifying in vectors zeros and ones. We are unable to find what is one, what is the one means. Yes, somewhere, some word, but what is the relationship between the words in that content? We are unable to find. So no contextual information. So there is no meaning. Suppose if we have word like bank, for any word we are giving only one value, no contextual information. Here, State Bank of India, the bank gives different meaning, and Bank of River, the bank gives different meaning. But if you apply 100 coding, this bank comes under unique only one time. We have to write in the vocabulary. These are the disadvantages. So to overlap disadvantages, we have some another method back of words. Some only represent technique used in NLP to convert text documents into numerical vectors. Okay, all these techniques are converted into numerical vectors. But here, it's a bag of words. A minute. A bag of words vector. It depends on the vocabulary depends on frequency. Represent frequency of corresponding words in the document. Previously, if thousands times same word repeats, we assign as a value one. But here we are giving some frequencies that gives some more important when compared to other. So here first, I love programming. I love programming NLP fun. So this is suppose any time I love programming. Suppose I love NLP. In that case, the it should be value 2 and now should be 2 for first sentence and NLP so 1. So likewise, the frequency instead of ones and zeros, I have to write some frequency values. Here clearly mentioned the cat sat on the mat. First sentence the repeat 2 times. That means the frequency. How many times it repeats? 2 times. So again D2 2 times. So here also some drawbacks. What is drawbacks? Only we change instead of ones and zeros, we are giving some frequency values. Okay, zero always zero, but instead of one, we are giving frequency value. But remaining things are all same. That is large, sparse, large vocabulary, and there is no semantic relationships, ignoring words, all those things. So coding part. And then coming to TF-IDF, this is better than previous two models. That is term frequency, inverse document frequency. How many times a single word repeats in a current document, and out of how many documents this repeats. Okay, this TF-IDF, okay, this TF-IDF have two product. The value depends on TF-IDF. So what is TF? Number of occurrences of term T in documenting. Documenting. How many times it occurs in a single document, a single line. Out of total number of terms in the document. How many terms in the document? That gives term frequency. The word itself term frequency. Term frequency. So IDF means inverse document frequency. That is logarithm. Here we use logarithm, log number of documents in the corpus by number of documents with term T in term. So that I will explain with one example, then you can easily understand. So the corpus, the total inflation has increased unemployment is the first sentence. Second one is the company has increased its sales. Second, the third one is fear increased his funds. So data pre-processing, that means after removing of data, okay, stop words. Inflation increased unemployment and the company increased sales. Fear increased pulse. So if you apply how many times, okay, we have to write all the vocabulary words here. Vocabulary means total words in the given corpus. So after that, influence in first sentence, it frequency is one out of how many words are there? One, two, three. So that's why 1/3. So there is no company in first sentence, so 0/3. So increased here one, again 1/3. Sales. Likewise, we have to prepare this. We have to prepare this one. So coming to IDF, total number of documents in the corpus. So documents means records. How many documents here? Three records. For I'm finding for first one inflation, total number of documents in the corpus three. Number of documents with term, the inflation term in them. Out of three documents, only one document contains this inflation. So that's why log of 3/1. Likewise, if you apply these to remaining words, tokens in the vocabulary, we'll get some values. So what is our final? Calculate product of term frequency and inverse document frequency. That is TF into IDF. Already previous slide we have TF values, that is 1/3. Here IDF values 0.4. So. Like that we have to calculate. So in this case we are getting some values, same values. But if you change, that depends on the text. If you change the text, suppose here the text is the cat sat on the mat, the dog sat on the mat is warm. So here if you apply this TF IDF, for first one we are getting 0.72, again 0.72, 42, 50, 54 and some other values. So we are giving importance to the term, how much the term important in the given corpus by using TF IDF. When compared to previous two models, one hot encoding and bag of words, these give some importance to the words. But here also, we are also facing semantic relationships. Only it gives the importance of a word, but not gives the relationship between previous one and after one. And also inefficiently and storage also issue. We are changing the values. Instead of frequency, we are giving some values, importance of the values. So it goes to word order. Here word order doesn't matter. I mean here it doesn't follow the word order. Here cat, after that dog, mat, sat. These are some disorder. It's not following the order for any of the first sentence, second or third. So coming to important topic, the word embeddings. Word embeddings in NLP are a type of word representations where words are phrases and mapped. So here some word embeddings. Actually, this is very important. This first one, Google Waterback and Stanford Glove, the fast track, fast text that's developed by Facebook research team. So word to vec, what we are converting every word to the vector format, but this technique name itself word to vec. So the glove that means global vector. The fast text. I will discuss the what are the main points in these embeddings. Then we move to next one. So okay, these are the introduction part. So one to vec gives some. Here we are taking some value like window size 2. That means the model will look at two words before and two words after the target word in the sentence. Suppose here the cat sat on the mat. We want to find the word sat here. Without this sat, if you give to the model, I mean give to the mission, how can the word to works? That means and target word is sat. The window sizes, if you take two, the first two before words are the cat and afterwards are the mat. On the two next two words. So output target, the model learns to predict the word sat using the context words. So we have to predict, we have to train the model like this with large corpus. The model will get the sat value, the vector space value, and after train the model, it will give some vector value. These both are almost same, are very near. So very near means the similarity between the two words, two vectors are very near means the probability is very high. So the model can predict the SAT. I will share once go through this. The programming part. Here limitations. Automatic representation word as a fixed vectors. The vector size is fixed. Even the data is there or not, no issue, but we have to work with the fixed size vectors. We have to train the model with fixed size vectors. And outer vocabulary problem. If the word does not appear in the training data set, sometimes we deal suddenly one rare word will come. So that the model or didn't try with that word. So at that time the model doesn't give the proper values or not predict. And what to it cannot generate, yeah, cannot generate it embeddings the values. And memory and computation complexity, automatic model on the large data set with a large vocabulary may require considerable resources, memory and computation. So all the limitations. So to overcome this, we have another model like GLOBE model, global vector. Yeah, the global vector for word representation is an unsupervised learning algorithm vector representation of words. Okay, it needs a huge data. For example, I took like this, but it needs a huge data. So it is unsupervised learning. I think all of you know what is unsupervised learning. So they doesn't have any labels. So based on the features of the words in vector space, all the words are put together, are close together. So here it was developed. in Stanford University, and the co-occurrence matrix record how often words co-occur with a given context window in the corpus. For example, I like deep learning, I like NLP, enjoying flying. So here I after like, I enjoy. So how many times I after I like comes here too, and enjoy one time. Remaining there is no after immediate occurrence. So likewise, like I two times. After like deep is there, NLP is there. So go to yeah deep one time and NLP one time. Like that we have to create one co-occurrence matrix. After this, instead the word meanings are encoded in the ratios of co-occurrences probabilities rather than the law frequency. So encoded with co-occurrence ratios. I have to put some ratios with respect to number of how many words in that. Okay, if you go through this formula, then this relation between the word vector, context vector, the bias terms of the words, and once if you see, you can easily understand. For this is globe and what to make this, we have to train with neural networks. So to neural networks to minimize the loss, stochastic gradient descent, SD, SGD. By using this, we can reduce the loss and we can improve the prediction of next word, based on the vector space or numerical format of a given sentence. We can do all those things by using this glow model. So we can download Gemsim package for this Word2Vec and glow models. After that, if you pass any vocabulary and also load glow related Wikipedia. Like Glow has a pre-trained, it has pre-trained Glow model. Pre-trained means already trained with all the vocabulary in the Wikipedia or resources like World Wide Web. So already that trained data is there. By using this data, we can easily giving predictions or giving vector space or numerical format values to the similar words. There also limitation is there, that is out of vocabulary. So word does not appear in the training data. Glow cannot generate its embedding. So main thing. And coming to fast text. So it's a fast open source library, text representation classification developed by Facebook. Here only the new thing is here the fast text breaks the word into smaller subword units such as the characters and gram. So n-gram means 1 gram, unigram, bigram, trigram, or the 1 gram means every word, every given sentence split into one word. Binary gram means every given sentence is split into two. First two, next two words. Like trigram means three parts. Here, for example, word apple is an n-gram size of 3 means the generated n-gram would be first AP, APP, PPL, PLE, LE like that. We have to divide or split the entire remaining things almost same as a what we done in glow. So for this, it's same thing remaining splitting that input text into individuals and applying here only one thing is character engram, not one word engram. Characters means character wise splitting and word representation vector embedding through training process. The word's final vector is some embeddings of its engram. So this is some time constant I would like to skip, and this is the important. What to back starts with auto vocabulary. It handles auto vocabulary. Remaining things, training speed is moderate, exceptional speed, and scalability, especially with large data sets. And coming to types of neural networks, so it's a world level classification. Recurrent neural networks, it holds recurrent, it terms recurrent applies that perform a same task over each instance of the sequence. So sequence means at a time where each neural network deal with a character or any word at a time, and it holds the instance, the values, the memory for a next instance. So this is increasingly popular for NLP applications in recent years. So just what is RNN? Applications of these RNNs are run for word level classification, and we use for sentence level classification and generating pages, recurrent rural to model sequences, and some parsing techniques. We use this one. So and we have LSTM, by LSTM. So for this, I will briefly conclude here. This LSTM holds the memory for a long time. It's a bidirectional. It travels from left context words values and left right words and attention mechanism. So if you use attention mechanism, it holds 1 minute. So in attention mechanism, at a time, the data can process parallel. In RNN, it uses sequential data, but if you use attention mechanism, so parallelly where the models can process, analyze the text, input text to the model train. So no time, so very big. And applications, same thing. So application we can go through slide. So coming to once, so ChatGPT and era of natural language processing. ChatGPT is a powerful language model, so capable of generating human-like text. How these ChatGPT and NLP models are different from traditional models like RNN, LSTM. So ChatGPT, these models trained with huge data and recent data. So after before 6 months back, after Andhra Pradesh elections over, after 2 months, I ran a model in ChatGPT. Who is the deputy CM of Andhra Pradesh? It gives Damodar an old person name. So it takes it took 2 months of time to generate or train a ChatGPT model. But nowadays the technology improved. So recently, 2 days back, we got Delhi government, I mean, elections over. So it tells up to this February 9th, the CM is so and so. After 11th, so some new government will form. So new data is updated. But in some ChatGPT or pre-trained the LLM models like DeepSeek, the DeepSeek is developed by the Chinese company. The Chinese company, if you ask some question like 1 minute here, I would like to, sir, I want to show some output or another tab here. So is it visible? This I am opening DeepSeek website. Anyone can tell is it visible or not? Are you seeing this website? No one is active. I opened DeepSeek website. Are you able to see? First, let me know at least. Can you find
Yes,
this
sir, it is.
website?
Yes, sir, it is visible.
Yeah. So suppose if I give where is the Arunachal Pradesh state in India or where is Arunachal Pradesh state, if you give to the DeepSeek DeepSeek website other than ChatGPT, it gives there is no state and immediately it removed because sorry that's beyond my current scope. Let's talk about something else because China is fighting for Arunachal Pradesh state with the India. So that's why these deep seek the company delete or not trained that data with that DeepSeek server. So this is ChatGPT, LLM models, all ChatGPT, DeepSeek, and I can use WhatsApp also. WhatsApp, Meta AI, all these things we can train our own models. Nowadays, Government of India also giving or seeking or call for proposals through India AI mission. So our build our own India AI models. So this is ChatGPT or that why I am saying all these things is okay, don't depend. Okay, whenever what you want up to that, okay, you can depend, but completely don't depend completely on these LLM models. So DeepSeek, okay, sorry, that's beyond my current scope. Let's talk about something else. Suppose same thing. An hour before I asked some question like, so what are the current news in India? What are the uh, news up to date news? If you type up to date news, it won't give the date up to date news. It gives only few days back the news. Likewise, so these are all 1 minute. uh, sir, what happened? Okay, the rise of conversation age, early chatbots, only the LLM models trained with chatbots, machine learning advancements. After that, emerging of LLM models. Nowadays, we are having supercomputers, all these things. By this computer hardware infrastructure, we are developing so many models. We are dealing with huge data, huge data, huge data. So models like ChatGPT and trained and vast amount of text data that gives nowadays we are interacting with chat gpts deepseeks and meta as and when google developed gemini ai so gemini ai gives the artificial images also. If you ask any image it will give images also. So maybe they are using gen ai, generative ai. Generative ai means they are dealing with audio video image uh, videos etc. And also every model has some limitations. So that limitation is bias in training data up to there is no up to date data, so don't depend on the as is data. Then you can before conclude that before analyze we have to take the data, we have to analyze it. And inability to access real-time information, that is inability. Lack of true understanding of content and ethical considerations in use of chat gpt. So, applications of ChatGPT in various industries, I think all of you know, all we know, for we need daily, we are using ChatGPT for all the purposes. Well, content writing and question and answering, and if we need any suggestions from the net, on healthcare, education, content creation, and challenges data privacy. Okay, sometimes if you not provide your website, if suppose you are the company ceo, if you put your data in publicly, the chat gpt can use your data and it can show your metrics or your values, your credentials to the publicly. And explainability and regulation, data privacy, integration chart GPT with other technologies, and speech recognition. We can computer vision allows chat GPT to understand the interpret images. Robotics, if you give anything, any instruction to the robot can do remaining things. So that's chat GPT internally works. So conclusion and this future outlook represents significant advance advancement in natural language processing. As the technology continues to evolve, we can expect even more innovative applications and deeper integration into our daily lives. So this is the introduction. Okay, LLM models. Chat GPT is one version of an LLM models. Chat GPT, all these things. LLM models means large language models. If you deal with large language models, then these are the supports. If I need medical related, only Chat GPT. All medical related, if provide the data provide to the these large language models, the model can act as a medical related Chat GPT. So it will give the accurate results in particular area like medical, sports, like that. We can create our own language models. Already repeated and applications again chatbots, machine translations, and text summarization, code summarization, all those things. Ethical considerations in LLMs, a future of LLMs and NLP, new application, LLM will use it in new and innovative ways, expanding their impact across various industries and domains. LLM will continue to improve. So due to up to this, I conclude and I have to show some paper also, but due to time lag, uh, like sir, so I concluded with this slide. So I would like to explain some paper, research paper also, and some coding also, but I'm unable to explain all those things with the time constraint. Like sir, is there a time? Is there?
Sir,
Like sir,
in
is
two
there
three
a time
minutes
left?
you show that, sir, in 2 3 minutes.
Okay,
So
okay,
give simply outlook of your paper and
okay,
give
okay,
us.
okay. Okay, I would like to show my three papers which I published in Elsevier, Plates of Computing Journal. It's a very high impact factor, almost 8 point something. Is the my first paper. That's why I love this paper, and also I worked a lot for this paper. So I worked on COVID-19 outbreak. Actually, I collected the tweets, the content from the web. I mean, one international conference. After that, so I tried three transformer models, so the Robota, CityBet, and BetTweet. Here I used majority voting. So what is majority voting here? Robota already gives good results, and the CityBet in sometimes it also gives for some data it gives good results. So BetTweet it gives good accuracy for some tweets. So I measured all these things and I used their voting. Okay, if you give some tweet to this model, the robot will give, okay, this is informative, and CTBit also gives informative. Out of three, two people are giving informative. That means majority voting. I consider voting of among these, those two at most webs. I mean, at most models give either true or false. Based on that, I will decide. This model will give the predictions. So initially, the models, individual models give uh, accuracy up to 89%, 89, 89.1, and 90%. If you apply this ensemble model, it gives a good result of 90, almost 91, 92. So this that's why this paper published in this journal. So for this I used this I tried. I mean I trained the model with so many hyperparameters like 1 minute. Hmm. So these are the learning rate. I tried all these batch size, various batch sizes, learning rate, keep on changing the batch size and learning rate. After that, some particular one point, I got a good accuracy. So I noted that accuracy. After that, I matched, I created a model with ensemble, all this for taking this majority voting of remaining models also. Okay, remaining models, city bet. For this learning rate is 1 e minus 5, the batch says 5, like that. Tried this model, and finally this ensemble model gives good accuracy. This is one paper. Okay, finally this proposed model MVEDL gives 91.14 F1 score and accuracy this. And also another model, a fake or real news about COVID-19 pre-trained transform model to detect potential misleading news. Here I used two models like Robota and CityBed. Here I used fusion multiplication. So here I changed the data set. Fusion multiplication, if you apply some multiplication, addition multiplication, then it will give some good accuracy, binary classification, either fake news or real news. In the pandemic, some fake news also spread. So this area is affected more, like that some fake news are spread more. To identify the type of wrong news or fake news, we prepared some model like this. This in this model, the main logic is the fusion vector multiplication. So by multiplication, I'm getting the good accuracy when compared to the individual results.
పెట్టు దండం పెట్టు పొద్దున ఏం చేయాలో తెలియలా నేను లేచాక తుడుతుంటే అటు ఇటు చూసి ఏదో చేశాడు ఏం రాస్తా
Okay, then
అదేదే
the third paper,
చెయ్యి
I would like to explain the third paper main logic. So here I used fuzzy systems, pre-trained transform models. The fuzzy system rules, I used fuzzy system rules, fuzzy inference, defuzzification, and I used here CTB two models. But here output layers in previous models they are giving either yes or no, I mean 0 or 1. But by using fuzzy system, the values may be 0.555. It may comes under S, but it's not in real time. It's not a good models. So for that, I framed some rules as well as okay, some fuzzification interface and develop a model. So with this help of fuzzification gives good results when compared to the griddle models. And also, if you want to do any NLP related research and NLP related any queries, any suggestions, always always ready to help you. Okay, this is thank you. This is my last paper. I mean, up to this, I would like to stop here. So, Mike sir, and also if you have any questions and any suggestions.
Yes, sir. Any queries from participant side?